Hello there. In this video, we are going to take a look at doing batch arrivals in the QPython package. In other words, there's this idea that you have arrivals coming into your system, and perhaps they come in kind of clustered groups or collections where maybe 5 at a time instantaneously arrive, or at least that even if it's random, that they're different sizes of collections each time. So in order to implement that, Q has provided a class that users can use. I was thinking about this, and there's actually a way that you could do this yourself with your own custom probability distribution. Maybe at some point we'll make a video on that, but suffice to say, you don't need to because it's implemented in the QPython package for us. Okay, let's skip the all caps and we'll go import Q, and then we'll set up our network class, q.createNetwork. And let's grab ourselves some arrival distributions, and we've got q.dists. And here we're going to keep it to deterministic distributions just for the sake of example, but really you could have all kinds of things here. And service, we'll get to service disciplines, which I'm looking forward to, but that's a different topic. Service distributions, and we'll also pick deterministic for that, assuming I spelled deterministic correctly, and following the documentation, we'll just set that to a value of 3. Okay, and then we'll set the number of servers to, let's say 1, but we want to add one more thing, which is to say this is the inter arrivals, this is the when, but when they arrive, perhaps we would like it to be the case that they arrive in batches, in collections of some size. Now, just this example from the docs is picking all the boring distributions here, but we'll get to that. So we got the batch distribution arguments that we can pass in to say not when they arrive, but when they arrive, how many arrive. And so here we can go Q, and we've got this example of deterministic again. And we'll say that they always arrive in batches of 3 at a time. Okay, so that's all you actually need to add, which is kind of nice. By default, all the time, it's more like implicitly they arrive 1 at a time. And so this is a generalization of sorts to say, well, each arrival, there's only 1 that arrives. This is to allow us to say, well, actually, when they arrive, 3 of them arrive, whatever they are. So we can set up our simulation. Let's call that q.simulation and pass in our network, and then let's simulate until some amount of time. Sure, we'll follow the docs and say 30. 30 is probably pretty good because we know that the first collection of arrivals will happen at time 18.5, and we should expect 3 of them, right? And then that gives also time for these folks to get served, so they should show up in the records as well. All right. It's just an example. It's just, you know, just to make things easy to analyze after the fact. So get all records. We'll grab all that data. And then maybe for the sake of showing some stuff, we'll go arrival times. And we'll do a formatted print here of r.arrival date for R. R here is the elements of records. And we'll close that list comprehension. It's not exactly how I'd recommend you set up your code in general, but we're just being a little bit rough and ready here. Arrival times, and let's also get the wait times as well. Waiting time for. And it says I need to do something about those semicolons. Looks good now. All right, let's run it. Batch arrivals. Values. It's not values plural. It is just value. Okay, so some things to notice here. One of them is that because they arrived all at the same time, the arrival times for all 3 are identical. Why are there 3 of them? It's because up here at line, whatever this is, relative is 2 down from my cursor, but that's not helpful. But anyway, batch distributions is because 3 of them is set to arrive. And when do they all arrive? Well, the arrival distribution says deterministically every 18.5, and this is the first time that an 18.5 occurs. And then the queuing, the number of servers at this queue is only 1, so they only serve 1 at a time. So the first one arrives and enters immediately. The other 2, because they arrived, will end up having this nice additive, because they arrived all at the same time, the other 2 will have this nice additive progression of, well, the next one had to wait for the first one that went in, and that's going to be 3 units of time because we've got a deterministic service time of 3. I guess I can see why they use this example now. It's very clean, easy math to follow. And then the last one had to wait for the first 2, and so that's 3 plus 3 is 6. So that's batch arrivals in a nutshell. And to summarize the use case there is to say maybe you get arrivals of collections of customers simultaneously, or that maybe you're modeling an emergency department and vehicle accidents maybe tend to come with collections of people that arrive in kind of clustered groups that are otherwise pretty sparse in time. To get that clumpiness, you might do something like having batch arrival distributions. Okay, with that, I hope you find that useful and can put that into some of your modeling, and I will see you in the next video. Have a good one.